Hello and welcome. Today, we're going to pull back the curtain on something we see every day. How in the world do our computers and phones create randomness out of thin air? Let's dive in. Have you ever wondered about that? How your music app can perfectly shuffle a playlist, or how a game can roll a fair die every single time? It really feels like magic, doesn't it? But it's actually a super clever process, and it's all based on one surprising little secret. And here it is, the secret. Computers can't actually be truly random. It's just not in their nature. So they fake it. They use something called pseudo-randomness. Now that's a fancy name for a simple idea. A computer just follows a really complex recipe, an algorithm, to create a long list of numbers that look so random, it's more than good enough for what we need. And in Python, our recipe book for all of this is the random module. Okay, first up, shuffling and choosing. Let's think about this like we're handling a digital deck of cards. Because, one of the most basic things we need randomness for is just mixing stuff up, right? Whether it's a playlist, a list of names, or, a deck of cards. So the first tool we're going to grab from our toolkit is random.shuffle. The name kind of gives it away. It takes a list and just mixes everything up. But here is the absolute key thing you have to remember. It shuffles the list in place. That means it doesn't give you a new shuffled copy. Nope. It permanently rearranges your original list. So if this is our list of cards, our digital deck, and we run random.shuffle on it, poof, the original deck is now in a completely new random order. The ace could be anywhere, the king could be somewhere else. It's a perfect digital shuffle every single time. But what if you don't want to shuffle the whole deck? What if you just want to reach in and pull out one random card? Well, for that, there's an even simpler tool. Random.choice. It does exactly what it says. It just pulls out a single random item from your list. So simple and so effective. All right, next section, generating random integers, or as I like to call it, rolling the dice. Shuffling is great for rearranging the things we already have, but what about creating random numbers from scratch? This is where we get into making integers, which is, you guessed it, just like rolling a digital die. For this job, we use the function random.randint function. You give it a starting number, which we'll call A, and an ending number, B, and it will hand you back one single random whole number that falls somewhere in that range. Now, if you remember one thing about random, make it this. The range is inclusive. That means both the starting number and the ending number are included as possible results. So if you ask for a number between 1 and 6, you really could get a 1 and you really could get a 6. This seems like a small detail, but trust me, remembering that both ends are in play will save you a ton of headaches later on. And actually using it is incredibly easy. To simulate a 6-sided die, you just call the function with your range, 1 to 6. And just like that, you've rolled a digital die. Before we move on, let's clear up a really common point of confusion. For whole numbers, you use randint. For decimal numbers, or floats, which we're about to talk about, you use a completely different function, random.random. Just keeping those two straight in your head is key. Okay, on to our third section, generating random floats, which is all about simulating probabilities. We've handled whole numbers, but a lot of the world isn't so neat and tidy. To handle decimals, we need a different tool. And its real superpower is modeling chance and probability. The function we use here is simply random.random. It's as straightforward as it gets. You don't give it any arguments at all, and it always returns a decimal number between 0.0 and 1.0. Now, look at the fine print there. It can be exactly 0.0, but it will always be less than 1.0. It never actually hits 1. So why is a random number between 0 and 1 so powerful? Well, think about it. It's a perfect stand-in for percentages. 0.5 is 50%, 0.85 is 85%. This makes it the absolute best tool for modeling anything based on chance. Let's make that really concrete. Imagine there's a 30% chance of rain. We can just tell our program, call random.random. If the number it gives back is less than 0.3, then it rains. If it's 0.3 or higher, the sun's out. We've just turned a random decimal into a real-world simulation. Pretty cool, right? But you might be wondering, what if I need a random decimal that isn't between 0 and 1? Like, say, between 5.0 and 10.0? Don't worry, the random module has you covered there too. For that specific job, there's a function called random.uniform. All right, our last section, your random toolkit summary. We've covered shuffling lists, picking integers, and generating decimals. So let's put it all together in a quick little cheat sheet. So here is our core toolkit. For mixing up a list, shuffle is your go-to. Just remember, it modifies the original list. For any random whole number, like a die roll, you're going to use randint. Just keep in mind that its range includes both ends. And finally, for any kind of probability or percentage, random.random is your best bet, giving you that perfect decimal between 0 and 1. If you can master these three functions, you can handle most random tasks that come your way. And that brings us to one final, really important thought. We started out by saying all of this is just a predictable algorithm. Now, that's totally fine for shuffling music or rolling dice in a game, but it opens up a huge question. If it's not truly random, what does that mean for things like digital security and cryptography, where genuine unpredictability is literally everything? Well, that's something to think about. Thanks for watching.